So this is lesson 4.4a in elementary algebra. The title of this is Applications, or if you want the evil title, Story Problems. And one of the things that we're going to do is cover 4 different ways to solve these story problems using substitution or elimination. So we're going to do number problems, interest problems, coin problems, and mixture problems, which we did, gosh, must have been back 2.6-ish time period. Where we are doing these. But one of the things the author says in the middle of page 195 under the introduction is that you're not going to use this in real life, that these are just skill building activities, and that you won't be using the real life math until you're in a higher level of math. But one of the sentences that he says, the last sentence of the first paragraph, if the problems we solve are upsetting or frustrating to you, and here's his answer, then you are probably taking them too seriously. Okay? So don't take these word problems too seriously. I mean, they're going to be hard. And as you learn anything new, you discover that learning things new is difficult. And that's what builds your skill. So as you struggle through these, just remember you're building your skill as well as getting frustrated. But one of the things that we're going to do with these problems, and just to give you a heads up with this, is that we are going to be creating 2 equations. We're not going to just make one equation and solve it. We're going to do 2 equations. So if we look at example 1 under the number problems, it says one number is 2 more than 5 times another. Okay, so one number is. So we've got an equal sign there. So one number is 2 more than 5 times another. So let's look and call the numbers that we don't know anything about, x and y. So let's call one number y, and it says it is 2 more than 5 times another. Okay, so I just wrote it out there for you so you could see what's going on. One number is 2 more than 5 times another. Okay, so it's 5 times another plus 2, and that's what this number is. This is equal to this. It's not equal to x. It's equal to x if we multiply it times 5 and add 2. Okay, so there's our first equation. And a lot of times you can get that in the first couple sentences, and then it will ask you another question, or give you another bit of information. Their sum. Who is there? There is x and y. Their sum is 20. Okay? So there's my 2 problems. Now, if I look at this, I realize that probably the best way to handle this would be through substitution. And the reason I say substitution is I already have a variable all by itself on one side of the equal sign. So when that is the case, usually the best option is substitution. So we're going to take whatever y equals, which is that, and we're going to put it in there. And I'm going to put it in parentheses. And because there is a plus sign here, I can just take the parentheses off without anything changing, and that's always the case. If that was a minus sign, it would be a different story. Add like terms. Notice my y has gone away. Okay, I'm going to divide by 6, and I get an x equal to 3. Now I take my 3, and I plug it in one of my equations. Let's take the easiest one. So I'm going to subtract 3, subtract 3. So my y equals 17. So my answer is 3, 17. Or you could just write it, because it is a story problem, x is 3, y is 17. So let's see if that's a true statement. If x is 3, 5 times 3 is 15, plus 2 is 17. Is that what the y equals? Yes, it is, so I know I did that one right. All right, so one of the things that they did, you'll notice, they only gave you one problem on numbers. And that tells you that the homework isn't going to be really too ridiculously complicated because they really didn't give you more examples here. But let's look at the interest example, which is example number 2. Mr. Hicks had $15,000 to invest. So that's his principal. That's how much money he had on hand to invest. He invested some at 6%. Well, how much did he invest at 6%? We don't know. So let's say X equals the amount of that 15,000 at 6%. Then it says that he invested the rest, which we don't know, so we'll put that as Y at 7%. I don't know why he didn't invest it all at 7%. He would have made more money, but anyway. If he earns $980 in interest, how much did he invest at each rate? So at the end of all of this, if he took the amount he made at 6% and the amount he made at 7%, he would have as an amount $980. So now we have to try to make some equations out of all of this. We know that if we took the amount he invested at 6% with the amount he invested at 7%, we know that he would get his $15,000. Okay, because he split that $15,000 up into two amounts. A bit at 6% and another bit at 7%, but we don't know how much that was. We know that if he took the amount he invested at 6%, X, and multiplied it, and we're going to change our 6% to a decimal. Always have to do that. Remember, you can never do math with a percent. You always have to change it to a decimal. But if he took 6% of the amount he invested plus 7% at the amount he invested, we will get how much money he made off his $15,000. And that's what we're interested in doing. So there are our two equations there. Okay, so we've got the amount he invested at 6 plus the amount he invested at 7. That gave us our $15,000. To find out how much money he made above that $15,000, we have to take the percent times the amount and the percent times the amount, and that will give us the total amount that he made, which is $980. So, two equations there. One of the things that you might want to do is get rid of the decimals. Again, I don't like dealing with decimals or fractions, so if we can get rid of these decimals, that would be great. So what position is this? This is 2 over from 6, or 2 over from the decimal, right? And this is 2 over. So that means we multiply the entire thing by a number that has 2 zeros, 100. So what that does is that changes this to 6x plus 7y equals, because all I'm doing is moving the decimal place over 2. And from here over 2. And on this one here, over 2. So it's right here now. I'm going to move it over 2, and it'll be there. So now I have 6x plus 7y equals 98,000. So my equation, let's kind of set this off here. My two equations look like this now. Oops. And $98,000. Okay, so there's my two equations, and this is where I'm going to start. I'm going to use substitution again, just because it's real easy to write this as x equals 15,000 minus y. So instead of writing it that way, I wrote it this way. And then that gives me a chance to, wherever I see an x in that top equation, I can put this in its place. So that, I'm going to go ahead and see if I can erase some of this stuff. I can't erase a ton of it, but at least if I can get some of it out of my way, I can keep going. Alright, so now instead of writing this, I'm going to put the 15,000 minus y in the x's place. I'm going to go clear over here to the left as I do that. So 6 times so see what I did? I just replaced this x right here with that. And then I'm going to go ahead and distribute. Okay, combine these. That's 1y. Subtract 90,000 from each side. And my y is 8,000. So I invested $8,000 at, what did it say? 7%. So $8,000 at 7%, which means out of that $15,000 I have $7,000 left, so that must have been the amount I invested at 6%. And I'm done. So let's look at example 3, coin problem. John has $1.70 in dimes and nickels. Okay, so if he took the amount, the number of dimes times their value, and added the number of nickels times their value, added all that up, he'd get $1.70. And he has a total of 22 coins. So if he takes his nickels plus his dimes and he counts them, he has 22. And the question is asking how many nickels and how many dimes does he have, so that when he adds them together, he gets 22. Well, you could just look at that one equation and say, well, he could have 20 nickels and 2 dimes. That would give me 22. But when I add all the values up, I get $1.70, which requires us then to make another equation. And we've done these nickels and dimes problems before. In order to figure out that he has $1.70, we have to take the value of a nickel times however many nickels he has, plus the value of a dime times the number of dimes he has to get $1.70. So notice there is and I had said this a long time ago, when they give you a decimal here, then you have to write the nickels and dimes as decimals. If this would have been 170 with no decimal, this would have been a 5 and this would have been a 10. 5 cents plus 10 cents equals 170 cents. But since it's dollars, $1.70, we have to change the dime to its dollar amount, 1/10 of a dollar, and 5 cents. Okay, so anyway, you have to change those to decimals if the dollar amount is in a decimal. Sometimes that's easy to forget, so just wanted to remind you of that. All right, so let's go ahead and change these to cents so that we don't have to deal with those. So all we're going to do is move that decimal over to, which the book did it this way. I would have, initially when I was doing this, I would have just taken that decimal away and written that as 5 and 10 to start with without going through the whole instruction thing that I just did. And above it, let me write my second equation here. And I'm going to do this using elimination, just because it's a different way of doing it. So let's multiply. We want to get our number of nickels or our number of dimes. We need the number in front to be the same as this one here, and it also has to be the opposite sign. So I need to make this either a -5 or this one here a -10, so it matches that. So the -5 is smaller, so let's do that. So I am running out of time, so I'm going to copy and paste this into the next video and continue.